Welcome. Let's try to solve another Leetcode problem 7, ways to express an integer as sum of powers. So let's just use the first example. So in the first example, we have a number of 10 and 2. So for this number 10, it's going to be 3 to the power of 2 plus 1 to the power of 2. So this x just means we're going to find a number. If this number to the power of this x value, so 3 to the number of 2 plus 1 to the number of 2, it is a 10. So how many ways? There's only one way. Yeah. And we want to return how many ways as it's going to be a really big number. So we're going to modular a mod. The mod is going to be this number. So how can we solve this problem? And let's just check what's going to be the maximum number we can choose. Because this n going to be 10, definitely we cannot get the final result more than 10. Yeah. So if we were to get the final result less than or equal to 10, so what's going to happen? And let's first check this x. So this x is going to be more than or equal to 1, less than or equal to 5. This means that x cannot be 0. So this is okay. This is helpful for us to solve the problem. So this means for the numbers we're going to choose, so for example, for the numbers we're going to choose cannot be more than 10. If it is a 10, it is okay. 10 to the power of 1, it is still 10. But what if we choose a number 11? But 11 to the power of 1, it's going to be 11. It's going to be more than this number n. Yeah. So this means while we are choosing the numbers, it can never exceed this number n. Otherwise, it's going to make mistakes. So this is helpful for us to use the 0, 1 knapsack to solve the problem. So the idea is that we're going to choose some numbers. So for example, this is n. So this means we're going to choose the numbers like 1, 2 until 10. And for this example, n going to equal to 10. But n can be maximum 300, but that is okay. So this means we're going to just choose some numbers. So for example, we're going to choose number 1, 1 to the power of x, 1 to the power of 2, and we're going to choose a number of 3, 3 to the power of 2, and it is equal to 10, and there's only one way. So what is this problem? This means for each of the number we can choose it or we cannot choose it. So this is going to be a 0, 1 knapsack. So after this number, we cannot go back. We have to go forward to the next number. So this is just the 0, 1. Choose it or not choose it. And after that, we cannot go back and we have to go forward to the next number. Yeah. Now let's just use this idea to solve the problem. So let's just prepare a nums. So it's going to be a list of range from 1 to n plus 1. So that's going to be all the numbers. And let's just make a reverse. So for reverse, why I'm gonna reverse it? This is helpful for us if we reverse the numbers, like for example 3, 4, 3, 2, 1. We can stop the DFS immediately, and this is a kind of trimming. So for example, if the target this n gonna be equal to 10, if we choose the first number 4, definitely it will not work, because 4 to the power of 2, it is 16. 16 is more than 10. It didn't work. So this is why we're gonna make a reverse of the numbers from 1 to n. Next step is that we're gonna check the total number of the numbers inside of the nums. We're gonna use a capital N instead of this lowercase n, because we just need to distinguish that. Yeah, this n is our what is given for this n. This is the target. Now let's just prepare the mod. It's going to be 10 to the power of 9 plus 7, and let's just write the DFS. So I'm going to define a DFS. So inside of the DFS, I'm going to start from the first index 0 and the total value for this target. Yeah. So what are we going to call? We're going to call this from 0 to 0 for the final result. First of all, we can check this target. So if this target is more than n, definitely it is not possible. So we're going to return 0. Otherwise, we're going to check if this I equal to n. So we're going to have two possible cases. So we can return 1 if this target t equal to what is given this number n. So otherwise, so we're going to return 0. This means there's no way. If it is 1, it means we found a way. Yeah. Then we just accumulate all the different cases. So for the next one, it can go to the next one, and we will not choose it, so it's going to be a t. and for the next one it's gonna be I plus 1, and we're gonna choose it. So if we choose it, what's gonna happen is that we're gonna choose the nums I and to the power of x. Yeah, but for those two DFS, we need to modular our mod because that's gonna be a really big value. Yeah, and our final return also gonna modular this mod. This is why we can return the DFS directly. Now let me just run it to have a check. As you can see, it works. Let me just submit it. As you can see, it passed all testing cases, although it is a little bit slow, but it is okay because definitely this is going to be a DT problem. And the time complexity is going to be this I times t, and I going to be n 300, and this t going to also be 300 as well. Because this t is also n, we are going to check, because if this t is more than n, definitely we're going to have a return, because yeah, in this way we can understand that the t gonna be maximum 300, so the time complexity gonna be n squared 300